Okay, when you evaluate this, you type in the key 7 to the power of, in parentheses, you're going to put the whole square root of 4.7. The first set of parentheses will close the square root. The second set will close off the power. You've already entered it as a decimal, so the display should be in decimal form. If we round it to the nearest 4 decimals again, we get 67.9405. Okay, so that's one of the things that you're going to need to be able to do with in this section with exponents is evaluate them on a calculator. The other thing is you're going to need to be able to use applications that involve exponential functions. Okay, and so the main one that we're going to look at is going to be compound interest. And compound interest looks like the following. A, your ending amount is equal to P, the principal value or the initial investment or amount, times the growth factor 1 plus R over N to the power of N times T. Okay, so let's talk about what each of these variables mean, and then we'll put it into an equation or put it into a problem and work through it. Okay, so A is the amount of money, the account balance. At time t. Okay, where whatever the t value is, this is the account balance at the end of that time. Okay, the p value is your principal or the initial investment. So it's the amount at time 0. Whatever you initially started with, that's your p value. R is the interest rate. And it's going to be entered as a decimal. And so what that means is if you took something like 5% was your interest rate, when you write it as a decimal, think about what the word percent means. Okay, per represents divided by, cent is 100. So you're going to take 5 and divide by 100, which means you move the decimal 2 places to the left, which gives you your decimal form 0.05. Okay, so make sure you enter the rate in percent form, or in decimal form. Okay, the n value represents the number of compoundings. I'll talk about that here in just a moment. Okay, and then finally, the t value is the number of years, the time. All right, so those are your values. You're going to be given all this information except for one of them, and then you're going to be asked to solve for that unknown. Now, the one other thing in doing this that you need to pay careful attention to is this idea of compoundings. Okay, this value for n, again, this is your n value. The value for n is determined within the context of the wording on the problem. Okay, so if they say that your item is compounded quarterly, what that means is the n value, it's compounded once per quarter, and so a total of 4 times per year. Okay, so what would the n value be if it was compounded monthly? N would equal 12. It'd be compounded once per month, so in a year, 12 times. What if it was compounded weekly? 52 weeks in a year. And what if it was compounded daily? Okay, so if you just plug in the information you have, your original investment is $19,000, so that's P, your principal value. Your interest rate is 4.7, so our R value is going to be the decimal form of that. Move the decimal 2 places to the left. We get 0.047. Our N value, because we're dealing with a quarterly compounding, it's going to be compounded how many times per year? Once per quarter, or 4 times per year. And so we're going to take that number, 4, and we're going to multiply it by the number of years, which is 8. Okay, so here's our equation. We can calculate that. 19,000 times 1 plus 0.047 over 4. Take that whole thing to the power of 4 times 8. Now, if you are going to manually calculate this, okay, so if you're not going to just mentally calculate it as 32 and enter that, you need to put it in grouping symbols. If you don't put these parentheses around the 4 times 8, it will give you the wrong calculation. The order of operations the calculator would interpret would be this whole thing to the power of 4, and then it would multiply it all by 8. Okay? So make sure you have parentheses around there, and you should get your answer to be approximately 27,611 and 91 cents. Okay, so that would be the value after 8 years if it was compounded, if interest was compounded once every quarter. Okay, what I want you to do is just take a moment here, and I want you to find out what would be the value if it was compounded monthly, weekly, and daily. You don't have to retype all of this every time, right? You should be able to see the only difference in all of these calculations is we replace the n value, which in this first case is just these two 4s, with the corresponding n value for each of these. And if we kind of go back to that, the monthly has how many compoundings? 12. Weekly is 52, and daily would be 365. So what we're going to do is we're going to plug these values in to our calculator. So starting with monthly, if we just re-enter, replace our 4 with a 12 in each of those instances, hit enter, and we recalculate this value to be 27,652.18. Okay, so you see it's a little bit higher. Okay, what if it was calculated on a weekly basis? Okay, here we're going to replace our 12s with a 52. So I just have to change the digit for 1, and I get the new value, 27,667.80. Okay, again, it's a little bit higher. Okay, what if I do it on a daily basis? If interest is calculated every day, so we change these 52s into 365 and calculate it, we get 27,671 and 83 cents.